Okay, good evening, guys. I hope you are doing fine, and I hope you can see my screen, and you can also get my voice. Okay, so someone was sharing these questions and was asking. Yeah, so these are the only questions we didn't solve from this tutorial sheet. Yeah, so let's try to solve some. Okay. The rest of the questions from 1 to 13, I think we solved. And the videos are there on Drive. If you missed them, you can watch from the Drive. Okay, so we are proving identities. Okay, so meaning we have to have the knowledge of the most common identities, like sine squared theta plus cos squared theta. We know that that is equals to 1. We must know the double angle formula, because we're going to use it here. I can see it. We must know the identity for tan. We must know the identity for cos, sec. We must know for cosec. Those simple identities, they are the ones that are going to help us solve whatever we are solving here. Okay. All right. So the first question here, it has a triple angle. Okay. So we use the double angle formula to solve that. Okay, so let's try to prove this guy. Okay, let's try to prove that whatever we have on the left is equal to whatever we have on the what? On the right. Okay, so the secret about identities is that always try to manipulate the one that looks complicated. Okay, the one that looks simple, leave it. Okay, manipulate the one that is looking complicated. Right, because it will be very complicated for you to make this guy here look like this, but it will be very easy for you to make this guy here look like that. Okay, so let's try to solve this question. So we have cos 3 theta. Okay, we have cos 3 theta divided by sine theta. Okay, plus we have sine 3 theta. So if I explain anything and you don't understand, please ask. Okay, over cos theta is equals to 2 cot, okay, 2 theta. So it's also important to know the identity of whatever you have on the right. So we know that a cot is the reciprocal of a tan. Okay, we know that tan is equals to sine theta over cos theta. So it means that the cot is just equals to what? It is equals to cos theta on top over sine theta. Okay, so here let's try to simplify this cos 3 theta sine 3 theta. Okay, so let's write it here. So cos 3 theta, let me write it like that. It is the same as if I write cos 2 theta plus theta. Okay, it's the same because I'm just adding theta. Okay, I remember I applied it in the last question. Okay, so it will be the same. Okay, so let's apply it. Okay, just a minute. Scrolling. Okay, let's continue. So this one here, we can apply the double angle formula. We know that for a cos, if I have a plus here, it means in a formula I'm going to have a minus, right? Okay, or maybe I should write it for the sake of those who are not here. So the formula states this. Okay, so if I have two angles, A and B, which can be anything. So if I have cos, very much. Okay, so if I have cos A plus B like that, okay, When I expand this using the double angle formula, it will be cos A, okay, cos B, and then since I have a plus here, I'm going to say minus sine A, okay, sine B. This is what you have. And then if you have a sine, and then you have two angles A plus B, okay, this will just be sine A cos B, and then we are going to say plus. So if it's a sine, plus remains, plus cos A, we exchange the angles, okay, and then sine B. Okay, so these are the double angle formula. Okay, so these are the formula that we are going to apply even here. Okay, so this angle here, the 2A, the 2 theta is acting like our A, then the theta is acting like our B, right? So we said this would be cos A, so meaning cos 2 theta, okay? And then multiplied by cos theta. And then since we have a plus and it's a cos, we are going to say minus sine 2 theta, okay? And then sine what? Sine B. So this is what we are going to have here, okay? Then from here, let's try to, okay, I think we can leave it here. So let's try to leave it here. Then let's get the sine 3 theta, okay? We also simplify it. So this one we said is the same as, I can write as sine 2 theta plus what? Theta. Okay, and then from here, what am I going to have? I'm going to have this. Okay, I'm going to have this. We said when we expand a sine, we're going to get sine 2 theta cos theta. And then since it's a sine and it's a plus, the plus remains. Okay. And then here, what are we going to have? We are going to change the angle. So it means I'm going to have cos 2 theta like that. Seen it? Here I'm going to have cos 2 theta, and then I'm going to have what? Sine theta. So this is what I get when I expand this guy. Okay. So here on top, we are going to put this guy. And then on top here, we are going to put this guy. And then we are going to add these and see what we are going to come out with. Okay. So let's write. So we have 2 cos theta minus sine 2 theta sine theta divided by, okay, divided by we had the sine theta down here. Okay, and then we are saying plus, and then we write down the identity for sine 3 theta, right? Okay, so sine 3 theta, it was this identity. So just copy it. So 2 theta cos theta plus, we have cos 2 theta, okay, and then sine theta. Okay, and we are dividing all this by what? We're dividing all this by a cos. Okay, then we are saying it's equal to whatever we have on the other side. Okay, so from here now, what are we going to do? Okay, from here, what are we going to do? Let's try to add these two. So if we add them, the common denominator will just be sine theta multiplied by cos. Okay, so we're going to have sine theta multiplied by cos theta. So this will be our denominator. And then here we are just adding this guy, okay, with that guy. Okay, so let's put the ones with cos 2 theta here. So we are going to say, oh, no. We have to multiply because the denominators are not the same. Okay, let me do this. So here we are saying sine into this guy here. What are we going to get? We are going to get cos. Okay, so we are multiplying cos throughout here. So this will be cos 2 theta and then cos squared theta. Okay, if I multiply with cos, then minus I have sine 2 theta. Okay, and then this sign here will multiply with cos, so I have sine theta and then cos theta. So don't get lost there. Be followers. Okay, so this is what I have. And then when I do cos into this, I'm going to remain with the sine theta. So this sine theta multiplied by whatever I have here, I'm going to have what? I'm going to have plus. Now the space is going to be, okay, so I'll write it like this. Sine 2 theta cos theta plus cos theta multiplied by sine theta, I mean. Okay, and then plus we have cos 2 theta sine theta. So this will be cos 2 theta. Okay, and then this guy here multiplied by another sign here. What? Sine squared theta. Okay, so this is what we have here. And then from here, what can we do? Okay, so we can try to put the line. Okay, and then we see from there the other step that we can. Okay, so here we have cos and cos. Then here we have sine and cos. Here we have okay. So here, what am I multiplying? This one here multiplied with this, then this I multiplied with that. Okay. Okay, so let me try this. Okay, so the ones who have cosine, cosine, let me try to put them together. Let me see what we have. So I have, okay, so in short here, guys, we can see that some of them they are going to cancel, right? Because look at this term. I didn't see it. So look at this term here. Okay, please go me. Okay. So look at this term here. So this term that I've circled here is sine 2 theta, sine theta, cos theta, right? And then also look at this term here. Okay, it's the same. And this one here is a positive term of this guy. Here, the difference is just here, the cos starts and then the sine. Here, the sine starts and then the cos. But we know that multiplication is commutative, right? So it means this guy here and this guy, they are going to cancel. Okay, so what are we going to do? This cos 2 theta, cos squared theta, and then plus cos 2 theta sine squared theta. So this is what we have. And then down here, okay, down here we are going to have the same sign, squared theta cos what? So this is what we have here. Okay. And then from here, what can we do? Okay, what can we do? We see that this guy here, let me change the color. Okay. So we see that this cos 2 theta and the cos 2 theta, they are common, right? So we can factorize them, guys. So we can factorize the cos 2 theta. And then we are going to remain with cos squared theta. Okay, so cos squared theta plus sine squared theta. And we know what that is. That is just what? 1. Okay, and then we're dividing all this by what? By sine theta cos theta. Okay, so guys, we know that cos squared theta plus sine squared theta is what? 1. So it means all this thing here inside here becomes what? Becomes a 1. So it means we are just dealing with cos 2 theta, okay, divided by sine theta cos theta. Okay, so from here now we're just remaining with one step. So remember when I wrote this way, okay? Remember when I wrote this formula here, okay? This formula for the sine. So now imagine if I have these two angles. I have theta plus theta here. So it means that I'll have this. I'll have sine theta, cos theta, okay? And then plus cos theta, sine theta, right? This is what I'll have. And we know that multiplication is commutative, right? So meaning this guy here is the same as this guy. So it means here we are just going to have 2 sine theta cos theta, or you can write 2 cos theta sine theta, okay? So cos theta here. Okay, someone is troubling me. Okay, sorry for that, guys. Someone is busy. Troubling. Okay, so we are saying, so here you can see that if I have sine 2 theta like that, okay, it's the same as what? 2 sine theta cos theta, right? Okay, so from here we can come up with the identity for sine theta cos theta, okay, with identity for this guy here. So what are we going to do? We're going to say if we divide both sides by 2, what are we going to get? We're going to get that the sine theta cos theta, okay, is equals to what? Is equals to this sine 2 theta divided by what? By 2. So this guy here that I've written down here is what we are going to use in our final step, okay? So master this guy here. You've seen this guy. We're going to take him, and then we are going to put him here where we have this. You've seen it, okay? So this will be equals to cos 2 theta divided by, because this line here means divided by, and then what is the identity for this guy, okay? The identity for sine theta cos theta, we said it was, where is it? We said it was sine 2 theta over 2, okay? So we're just going to replace here. We're going to write sine 2 theta over what? Over 2. And then we know that here we can cross, we can do the switching there. The 2 goes up, the sine 2 theta goes down, okay? Okay, so let's do that. So if we flip this, it means the 2 will go up. And then this sine 2 theta will come what? Down, right? Okay. So what are we going to have here? We are going to have cos 2 theta multiplied by 2 and then divided by what? Sine 2 theta. Okay. And we see that this will just be 2 multiplied by cos 2 theta divided by what? Sine 2 theta. Okay. So what is the identity for cos 2 theta over sine 2 theta? Or if you have a cos divided by a sine and they have the same angles, okay, that identity is what we call as the what? The cot. Okay, so this is what we are going to have. So this will just be 2 cot 2 theta. Okay, so this is what we are supposed to have on the right hand side. So we can say hence proved. Okay, so any questions there, guys? This is what we had on the left. Yes, you can see this guy here. We found it. Okay, from this complex thing that we had, we are ending up with this. So any questions before I go to the next question? Okay, no question. So I'll proceed. So let's look at the other one, the identity. Okay, so we now have a sine squared x. Okay, so x is acting as our angle, and then divided by 1 minus cos x is equals to 1 plus cos x, right? Okay, so we want to show that whatever we have here is the same as this. So this one here, this question here, guys, the simplest here. Okay, so this is why. Let me show you. So here we have sine squared x, okay, is equals to, here they said 1 plus cos squared x. You just have to know how to apply the difference of two squares. So here you have 1 minus cos x. Okay, so we know that sine squared x plus cos squared x is equal to 1. Okay? And then we also know that we can express the sine in terms of the what? The cos. So if sine, let me write it. So sine squared x plus cos squared x, okay, is equals to 1. Then we know that sine squared x is just equals to what? 1 minus cos what? Squared x. We all agree, right? So whatever we have here, we are going to replace with 1 minus sine squared x. So I'm going to write 1 minus, that is cos, I mean, not sine. Then divided by 1 minus cos x is equals to the right-hand side. Okay? So what we identify here is that whatever we have on top here, it's just a difference of two squares. Okay? So if I have a squared minus b squared, this is the same as a minus b. Okay, in the first bracket, and then in the other bracket, I write a plus b. Okay, so I know that this one has a perfect square because when I do 1 multiplied by 1, it gives me 1. Or I do the square root of 1, it will give me 1. And then even this cos is squared. So when I do cos multiplied by cos, I'm going to get squared. And then if I do square root of cos, I'm going to get, if I do square root of cos squared, I'm going to get cos. So both of these here are perfect squares. Okay? So since they're perfect squares, okay, this will just be a difference of two squares. As long as the sign here is a minus. Okay? If it is a plus here, what I'm saying can't work. So always make sure that there's a minus. So this will be minus 1 minus the first one was x. Okay, and then the other one to be 1 plus was x, like this. And then we are dividing all this by what? 1 minus cos x. And then we are claiming that this guy should equal to the what? Right-hand side. So from here, we can see that it really equals to the right-hand side because 1 minus cos x, 1 minus cos x, they are going to cancel. We are going to have 1 plus what? Cos x is equals to whatever we had on the right-hand side, which was still 1 plus cos x. So hence we proved. So this is how we prove this one. So you can see that this one is simple, right? Because we are just using the difference of two squares, and we're also using the identity for the cos sign. Okay, so any questions there? Any questions, guys? Any questions? Okay, I'll go to the third one now. We'll try to solve it. Okay. So on number C, I have this question. So I have 1 over 1 plus cos x plus 1 over 1 minus cos x is equals to this. So whatever we used here is the same thing we're going to use here. So how? Let's see how. So we have 1 plus cos x, and then we are saying this plus 1 over 1 minus cos x is actually equals to what? Is actually equals to 2, and then here we have a cosec squared x. So this is what we have, right? So you must know the identity for this guy. For the cosec, is just 1 over sine, right? Okay. So we aim to make whatever we have here to be a 1 over sine. Then we would have found our answer. Okay, so what are we going to do? We are going to say the common denominator here will be 1 plus cos x in the brackets. Then in the other brackets, it will be 1 minus what? Cos x, like that. Then this should be equals to the right-hand side. Okay, so what do we see here, guys? We see that whatever we have down here, guys, is a difference of 2 squares, right? I don't know if you can see it. Okay, but anyway, before that, let's divide. So 1 plus cos x, it goes into this. Well, it's going to cancel with this guy. We're just going to remain with 1 minus cos x. So here I'm going to write 1 minus cos x. And then I'm going to say plus 1 minus cos x into this guy. This and this will cancel. We're just going to remain with 1 plus what? Plus cos x. So we see that the cos x and the minus cos x, they are going to cancel. So we are going to remain with 1 plus 1. So this will be 2 on top divided by, and then this one here, what we have down here is a difference of 2 squares. If you want, you can expand here. You can say 1 multiplied by this multiplied by this, but whatever you're going to get to just be 1 minus what? Cos squared x. Okay. Then this should be equals to the right-hand side. Okay, and then from here we know that 1 minus cos squared x is just sine squared. So this will be 2 over sine what? Squared x, which will be equal to the right-hand side. So this is what we have here. And then from here, we can separate the 2 and then we say multiplied by 1 over sine squared x. This will be equals to the right-hand side. And we see that the 1 over squared x is our cosec, right? This one here. So it means we are going to have 2, and then this one here is just the cosec, like that. Squared x, which is equals to the right-hand side, is proved. So we have proved here. Okay, so any questions there, guys? Okay, so that is it about identities. I also posted a video. I think that, yes.
With me, I don't know. Maybe on the videos, when you post the videos, I repeat watching because I haven't understood on C how you came up with the answer there.
Where should I start from? Okay, so this is the question C, right? I'm starting from here, right? Okay.
Yes, sir.
So we want to prove that whatever we have on the left here is equal to this guy here. So I said when you are proving these identities, you always have to start with the side that looks more complicated, okay? Because it is easier to make it simpler, okay? So we are starting with this guy, okay? So we add these two. It's like we are adding fractions, okay? So we find the common denominator. So we are just going to get the product of this and the product of this. So it's what I wrote here, okay? And then from there, we are saying this 1 plus cos x divided into this whole product here. It means it's going to cancel with the 1 plus cos x, right? Then we're going to remain with 1 minus x. And then this 1 minus cos x, you multiplied with this 1, we're going to get the same thing. Okay? And then we also get this 1 minus cos x, we divide it into this whole thing here. It means this and this, they are going to cancel. So it means we have remained with 1 plus cos x, right? Then this 1 plus cos x, we are multiplying it with this 1. So it's what we get here. We get the same. Okay. And then from here, we see that this is minus cos x, and then this is plus cos x. And they have equal magnitude. So they are going to cancel. So what are we going to remain with? We are going to remain with 1 plus 1. So it's the 2 that I wrote here. Okay. And then down here, I'm going to expand this. Okay. So maybe I didn't show the expansion whether you are correct. So let's expand. So 1 multiplied by this 1, I'm going to get 1. 1 multiplied by minus x, I'm going to get minus x. Okay. And then let's multiply with the cos x now. So cos x multiplied by 1, I'm going to get a what? Positive cos x here. Right? And then a cos x multiplied by a minus cos x. I'm going to get what? I'm going to get minus cos squared what? X. So you can see that whatever will be in the middle here is going to cancel out. So I'm just going to remain with 1 minus cos squared. So this is what I wrote here, right? And then we know that from cos squared theta or squared x plus sine squared x is equals to 1. So this identity that I wrote here, where is it? This one here. Okay, we know that sine squared x is equals to 1 minus cos squared x, right? So here where I have my 1 minus cos squared x here, this is the same as sine squared x. Okay, so I'm going to replace this guy now with this. So I replaced this guy with this. Okay, and then I can try to separate the trigonometric fraction from the number that I have. Okay, so I write 2 multiplied by 1 over this same thing. It's the same thing because when I multiply 2 multiplied by this, I'm still going to get this, right? Okay, and then this one here, the 1 over sine, it's an identity. It's the cosec. Okay, it's the cosec. It's one of the basic identities that you must. Okay, so since the sine here is squared, it means even the cosec here will be squared. So this whole thing here becomes cosec squared x, and then I'm multiplying by 2. So I get what? 2 cosec squared x, right? Yeah. So I don't know. Has it made some sense now on how we are getting it?
Yes, I have understood now.
Okay. Awesome. Okay, so that's about the identity. You have to go step by step. You have to know those basic identities. Okay, you have to know the basic identity. Okay, and then for these graphs, I think I already did the video for this. So you can watch this on Drive. I want us to revise some of the questions. The quiz that you wrote. Okay? So for the graphs, I already did this, so you can watch the video. Stay on Drive. Okay, and then let's revise some of the questions you wrote in your quiz. So this was your quiz too, right? Because some of the questions we can repeat them in the test. Okay. Okay, so the first question there is on relations, okay? And what a function is. So we know that a function is just a mapping that maps all the members of the input, okay, to one unique member of the output. So here they are saying which of the following is true about this relation. Is happening to my friends. This relation that we've been given. Okay, which of the following is true? So they're saying R is a relation, but it's not a function. Okay, but they're also saying R is not both a relation and is not a function. They're saying R is both a relation and a function. R is not a relation, but it's a function. So you can first start by cancelling out the obvious. Okay, the ones that are not answered here. So like B here cannot be an answer. Even D it cannot be an answer. Why? Because any mapping that you've been given is a relation. Okay, so you cannot have something not being a relation. As long as it's a mapping, it's a relation. Okay. So this guy here, the D and the B here, they are wrong. They're obviously wrong. Okay. So you are remaining with A and what? C. So let's see. So we know that this guy here is indeed a relation. But is it a function? So that's the only thing we are trying to find out. So for a function, we said one unique element of the domain should be mapped to one unique element of the range. Okay, so these numbers in first positions here will occupy the what? The domain. So we are going to write 1, 2, 3, 4. Okay, so I've gotten these first numbers, these ones here. Okay, and then let me map them. So this one maps to what? 2. The 2 maps to 3. The 3 maps to 4. And the 4 maps to what? 5. So you can see that each member of the domain here is mapped to a unique member of the what? Of the range. So this one here is indeed a function. Okay, and we already know that it's a relation. Okay, so what is the answer there? We can see the answer is clearly what? C. So C is the answer there. Okay, so that relation is both a relation and it's both a what? A function. Okay, so any mapping that you've been given is a relation. But what differs is it is a function or it's not a function. Okay, so know the definitions. Okay, and then this is partial fractions. So they are saying according to the method of partial fractions, there is an equation of the form. Okay, so they have given us this equation here, and it has linear factors in the denominator. So it's simple, this one, because it has linear factors. So what are we going to do in order to find the values of A, B, and C? We're just going to multiply throughout by the denominator that we have on the what? So you get this denominator here, the 1 minus, the x minus 1, x minus 2, and then x minus 3, okay? You multiply throughout this whole expression. So if I get this guy and multiply on the left-hand side here, it means this guy and this guy is going to cancel. So what are we going to do? We're going to remain with x is equals to, and then if I multiply this multiplied by a over x minus 1, means this x minus 1, they are going to cancel, right? So what are we going to remain with? We are going to remain with x minus 2, x minus 3. So I'm going to write a, and then x minus 2, x minus 3. Okay, it will be the same scenario for b and the c. So what will cancel, it will just be the x minus 2. And then here, what will cancel will be the x minus 3. So what I'll have is something like this. Let me write it. So here I have x minus 1 and then x minus 3. Okay. And then on the other one, I'll have what? X minus 1 and x minus 2. Then x minus 1 here like that. Okay, what is happening now? Okay, so this is x minus 1. Out of space, but there's x minus 1. Okay, and then from here, you just have to expand. Okay, you just have to expand. Here we say x is equals to, okay, so a, and then we expand whatever we have here. So this is x multiplied by x squared. X multiplied by minus 3x, I'm going to get minus 3x. And then minus 2 multiplied by x, I'm going to get minus 2x. So minus 3 and minus 2, they're going to give me minus 5x. And then minus 2 multiplied minus 3 is plus 6. Okay, and then plus, we have a b now. So x multiplied by x is going to be x squared. X multiplied by minus 2 will be minus 2x. And then minus 1 multiplied by minus x will be minus x. So this will just be minus 3x. And then 1 multiplied by minus 1. This is minus 1 multiplied by minus 2. We're going to get plus positive 2 here. And then plus c. We also do the same. So here we have x minus 2 1. So what are we going to get? We're going to get x squared plus, okay, so this one here was 3. It wasn't 2. Okay, so this one here was 3. Right? So this, here I'm supposed to have 4. And then 1 multiplied by that, this should be 3 like that. Okay. And then here, that's where we're supposed to have 3 and a 2 at the end. Okay. So here you have minus 3x, then plus 2. Okay, and then from here, we multiply by the a's, the b's, and the c's. Okay, so we are going to say a squared, or maybe I should group them. Anyway, should group them just from, okay. So I hope you'll be seeing what I'll be doing. Okay. So the ones that have x squared here, okay, it will be a multiplied by this, a squared, b squared, c squared. So I'm just going to write a plus b plus c, and then in the brackets I write x squared outside. And then for the x's, I'm going to do the same. So I have I have a multiplied by minus 5x, b multiplied by minus 4x, c multiplied by minus 3x. So I'm going to write here plus of minus 5x minus, oh, no. What am I? I'm supposed to write minus 5a. So minus 5a minus 4a. This will be b, not a. Then minus 3c, and then I have x outside. Okay. And then for the constants, I'm going to do the same. Okay, so for the constants, it's going to be plus, we have 6a plus 3b plus 2c. Yeah, so this is the equation that we have. We know that we don't have any term that is that has x squared here. So it means a plus b plus c will just be equals to what? 0. And then do we have a term that has an x? Yes. So what is the coefficient here is 1. So this minus 5 minus b minus 3 will be equals to 1. And then do we have a constant here? No. So it means 6a plus 3b plus 2c is going to be equals to 0. Then we can solve that to find the values of a and b and c. Okay. Let me solve it here now. So the first one, we have a plus b plus c is equals to what? 0. Then we have minus 5a minus 4a minus 3a. Why am I writing a's? Someone is disturbing me. Okay, so this will be 4b and then c. We said this are equals to 1. And then the other set was, let me check. Where is that? The other set was 6a, 3b, 2c. Okay, so meaning of this 6a plus 3b plus 2c is equals to 0. So we can solve these equations here to find the value of a and b. Okay? So we can say c will be equals to minus a minus b. And then we substitute it into the first equation, and then the second equation. So this will be minus 5a minus 4b. And then I have a minus 3, that is multiplying minus a and minus b. So that will be plus 3a plus 3b is equals to 1. Okay, so I have minus 5a plus 3a. So this will be 2a minus 2a. Then minus 3b, I mean minus 4b here plus 3b. So I have minus b is equals to 1. So we can say that b is equals to what? Minus 2a minus 1. So we keep this here. We're going to use it. And then let's substitute C again into this function. So we have 6A plus 3B plus we have 2, and then we are multiplying with this. So let me multiply. So we have a positive 2, that is multiplying minus A minus B. So what are we going to get? We're going to get minus 2A minus 2B, and then this is equals to 0. So we are going to get this. And then 6A minus this, we are going to get 4A. 3B minus 2B, we're going to get plus B is equals to 0. Okay, so B here can be equals to what? Minus 4A. So we have two equations for B now. B is equals to 4A, and B is equals to minus. B is equals to minus 4A, and then B is also equals to minus 2A minus 1. So we can equate this guy to this guy. So we are going to say minus 4A is equals to minus 2A minus 1. So like terms together, this one comes here. So it will become a positive. So it's minus 2A plus 2A is equals to minus 1. This will be what? This will be minus 2A is equals to minus 1. So it means A will just be what? Positive half, like that. Okay, so after finding A, let's find B. So B is equals to this one, minus 4 multiplied by A. We know A is half, so we put A. So what is the half of minus 4? The minus 2. So now we have the values of B and A. We can find the value of what? C. So C, we said it's minus A minus B. Okay, so C will just be equals to minus A minus B. So let's substitute. So this will be minus, no, this is a positive like that, and then minus 2. So what are we going to have here? Negative multiplied by negative is going to be positive, and then this one here is going to be minus 1 over. So what is 2 minus half? It will be 3 over. So C here is just 3 over. Okay, so this is the answer here. Yeah. So I know the process is long, yeah, but you just have to do it step by step. If you want, you can use substitution method. It will still give you the same answer. So here, when you come on your options here, where are your options? The quiz should come here. Yeah. So this 3 over 2 here was the answer. Okay. Right. So if you have any questions, you can ask. Okay, no questions. Let's solve this one here, number 2. So they're saying find the solution set of the modulus of 2x minus 4 is greater than 2. Okay, I remember I taught this. So I said whenever you have a modulus, it means you can have a negative and you can also have a positive, right? So the first equation, you just write the way it is. So 2x minus 4 is greater than 2. And then you say 2x is greater than 2 plus 4. So this will be 2x is greater than what? 6. And finally, x is greater than what? 3. So this will be your first answer here when you take it as a positive. And then when you take it as a negative, it means on the other side, you have to include the what? Minus sign. So it means we are going to have 2x minus 4 is greater than minus 2. This is what we are going to have. Okay, so like terms together, we're going to have 2x is greater than minus 2 plus 4. So this will be 2x. Have I done the correct thing here? I think no. Okay, let's see the final answer. So this will be 2, and then okay, I forgot to change the sign here. 1. Okay, so here when you include a minus here, you must change this sign here to a less than. Okay, so this sign should be a less than here. I'm going to change the sign. So you have this, so minus to be less than like that. Okay, so here to be x is less than what? 1. So if 3 is greater, I mean, if x is greater than 3, then it means the values will start from 3 point something, very small number. Okay, as long as it's greater than 3. So we can represent this as a solution set as this. We can say 3, because the 3 is not included here, we are writing this curve bracket, right? And then we are going all the way to positive. Okay, so this is the first part for this answer. Then for this part here, we are saying x is less than 1. So we are not including 1, but we are coming all the way from minus infinity to 1, like this. Okay, and then you unionize these two. That will be your final answer. So we see that the answer here will be this one on C. Okay, so you unionize this guy with this guy here. So the answer is C there. And then here they're saying which of the following functions is not one-to-one? It's very easy to see. So one-to-one, it means one element of the domain is
Sir, what's the difference between options C and D?
Okay, so for option D here, we have this kind of bracket. So this one here means the 3 is included. Okay, but here the 3 is not included. It's not included. We are getting values that are greater than 3. You've seen it?
Yes, sir.
Yes. Okay, so which of the following functions is not one? Okay, anyone who can try. Which of the functions here is not one-to-one? Even give us a reason. Okay, guys. No one is coming. Okay, let's check. Okay. This one here, we have 0 mapped to 1, 1 mapped to 2, 2 mapped to 3, 3 mapped to 4. They are all mapped to different things, so it's 1 to 1. Then this one here, 0 to 0, 1 to 1, 2 to 2, 3 to 3. Is it 1 to 1, this one? Okay, so we can put a question mark here. Come back for it. And then this one here, we have 0 that is being mapped to 1, and we also have 3 that is being mapped to 1. So type is, I'm going to say 1 to 1. So this one here, this C, is not 1 to 1 because we have two things that are being mapped to the same thing. So that will make it many to 1, right? Okay. So this one here is 1 to 1. Even this one is 1 to 1. Even this one here down is 1 to 1. But this one here, we have a 0 that is mapping to 1. Okay. Then the 2 is mapping to 4. And then we have a 3 that is also mapping to 1. So we have two things that are mapping to 1. So this one here on C is not 1 to 1. That's the answer. Okay. And then we can look at the alpha and the beta roots. So they're saying given that alpha and beta, they're saying given that alpha and beta are the roots of this quadratic equation here that is given, okay, this one here, find the equation whose roots are beta over alpha plus alpha over beta. Okay, so what are you supposed to do? You're just supposed to find the sum of these roots and the product of their roots and then put them in that general equation that I gave. So the new equation, let me write here. The new equation here is always in the form of x squared minus, okay, sum of the roots, x, and then plus product of it. So we just want to find this sum here and the product here, and then put them into the equation. That's all. Okay. So before we find this sum and this product here, we must find the sum of the roots from this equation and the product of the roots from this equation. So I have x squared minus 3 plus 5. So that's fine. So x squared minus 3x plus 5 is equals to. So the first step is to get your A, your B, and your C. So my A here, I can see it's 1. B, it's minus 3. C, it's 5. Okay. So we know that sum of the roots is equals to what? So alpha plus beta is equals to what? Is equals to what, guys? I've forgotten. What is alpha plus beta?
It's negative B over A.
Yes, okay, so negative B over A, and then alpha multiplied by beta, you're just going to have a C over A. Okay, so let's find the sum there. So alpha plus beta, we are going to get minus B over A. So minus B, so the B has a minus. So this minus and this minus is going to cancel. So it's something like this. Then you're dividing 1. So this will be what? 3. And then alpha multiplied by beta will just be equals to C over A. So C is 5 divided by A. You're still going to get 5. So now let's find the sum and the product for those new roots that we are given. Okay. So what root were we given? Here we have beta over alpha, alpha over beta. Okay. So it's fine. So we have beta over alpha plus alpha over beta. So let's add this. So the common denominator we see here is just going to be what? Alpha beta. Then alpha into this guy is going to give you beta. And then this beta multiplied by beta will be beta squared plus beta into this guy is going to give you alpha. And then alpha plus alpha multiplied by alpha to be alpha squared. Okay, so we know the identity for this guy. Everyone should know because this is the most common identity. Okay, so what's the identity for this guy here? Alpha squared plus beta squared. What's the identity there? What's the identity, guys, for this guy here on top? Hello? Guys, you're writing a test tomorrow. What's the identity here? Okay, anyway, I'm going to write it. But make sure you know it. So the identity is alpha plus beta squared and then minus 2 alpha. So this is the identity. Okay, and then over alpha beta. So why are we doing this? We want to make sure that our expression is entirely in terms of the sum and the product. Okay, so this is the sum. We know its value is just 3. This is the product. We know its sum is 5. So let's replace. Find the value of the. This was the what? The sum we're adding here. So this will be alpha plus beta is 3 squared minus 2 multiplied by 5. And then we're dividing by 5. So we are going to get, this will be 9 minus 10. So this will just be minus 1 over 5. So it means our sum is minus 1 over 5. Then let's find our product. So we have beta over alpha multiplied by alpha over beta. So we're going to get alpha over beta divided by alpha over beta. Okay, so what is alpha over beta? It is 5. What is alpha multiplied by beta? It's still 5. So this will just be what? 1. So the product is 1, and then the sum is minus 1 over 5. So it means our new equation, x squared minus, the sum is minus 1 over 5, x, and then plus 1. So this is the new equation here. And then you just multiply everything by 5 so that you get rid of this fraction here. So you multiply everything by 5, we're going to get 5x squared minus this minus and this minus plus x plus 5 is equals to 0. So this is the new equation here. Okay, and then where do we find it on the options? Okay, so you can see it. It's, is it the last one here? This one here. So that's our answer there. Okay, the D is our answer there. Okay. All right, and then number 6, they're saying the expression 3x cubed minus alpha x squared minus x plus beta is exactly divisible by by x minus 1. So what does it mean to be exactly divisible? It means the remainder there will be 0. Okay, and then on division with x minus 2, it gives a remainder of 21. Calculate the value of alpha and beta. So this is very simple. Okay, so since they said it's exactly divisible by this guy, it means when I replace a 1 into this function, I should equate it to 0. So I'm going to say x minus 1 is equals to 0, which simply means x is equals to 1. Okay. Then I get this one, I replace it into this function. So I'm going to say p of 1 is equals to 1 to the power 3, which is just 1. Then minus alpha multiplied by 1 squared, which is just 1, so it will remain alpha. Then minus 1 plus beta. And then we know that this one here, because it's exactly divisible, it's going to equal 0. Okay, so it means 1 minus 1, they're going to cancel each other. So we are going to remain with minus alpha plus beta. So we can write it as beta minus alpha is equals to 0, which is the same as what? Alpha is equals to beta. So that's what we get from the first equation. And then from the other one now, okay, we are going to get a remainder of 21. So meaning when we get this factor here, okay, x minus p is equals to 0, it means our x is just equals to what? 2. And then let's replace this 2 into this function and then equate it to what? 21. So it's going to be 2 to the power 3. It's going to give me what? 8. Then minus alpha. What is 2 squared? It will just be 4. So I'll write a 4 in front here. Then minus, what is the x? The x is the 2. I'm going to write 2 plus beta is equals to what? 21. Okay, and then from here, 8 minus this 2, we're going to get 6. And then I have minus 4 alpha plus beta is equals to what? 21. But we know from the first one that alpha is equals to beta. So here I'll just put alpha where the beta is. Okay? I'll put alpha here. So if I put alpha there, what am I going to have? I'm going to have minus 3 alpha. So this will be 6 minus 3 alpha is equals to what? 21. Okay, I hope we find an answer here. So minus 3 alpha is equals to 21 minus 6. Okay, do we find an answer here? Can't see it. 21 minus 6 is what? That's 21 minus 6. Okay, will it be 15? Yeah, 15. So 15. Okay, and then you divide by minus 3, divide by minus 3, means your alpha will just be what? Minus 5. And since alpha is equal to beta, it means even the beta is minus 5. So you come on your answers here, you choose where you have minus 5, which is what? A. Okay. Right. Okay, let's look at question number 7. So question number 7 is saying let a function that maps real numbers to real numbers be defined by f of x is equals to 5x to the power 3 minus 8. Okay, so they are saying what type of function is this? Is it one-to-one function? Is it an auto function? Is it both one-to-one and auto? Is it many-to-many? Okay, so what can you see? Okay, so let's I can see this is a one-to-one function, but how do you prove it? So you find f, I think let me draw it on the board here. Okay, so we have this function here, f of x is equals to the power 3. I think I've written the wrong. Okay, 5x to the power 3, okay, minus 8. That's correct. So this is the equation that we have. So I have to find f of a. So f of a is what? It will just be 5a to the power 3 minus 2. Okay, then I find f of b is equals to 5b to the power 3 minus 8. Okay, and then I equate this f of a to f of b and see if I'll end up with a is equals to b. If I end up with this relation here, I'm going to conclude that this function is one-to-one. Okay, so let's do that. So 5a to the power 3 minus 8 is equals to 5b to the power 3 minus 8. So we see that if you take one of these to the other side, they are going to cancel. So we're going to remain with 5a to the power 3 is equals to 5b to the power 3. Divide by 5 both sides, we're going to have a to the power 3 is equals to b to the power 3. Okay, you take the cube root of this, you also take the cube root of that, you're going to remain with a is equals to b. So the function is one-to-one. Okay, so a cube root is unique, but a square root is not. Okay, so if we had a square root here, it means we can't get this relation here. Why? Because when I do a square root of something, okay, I'm supposed to get a plus and a minus. Okay, so a minus of this cannot be equals to a positive of that. So it can't work with a square root, but with a cube root or a fifth root or a seventh root or a ninth root, it works. Okay, so since we are able to get this relation here, we can conclude that the function is one-to-one. Okay. Okay, so this function, where is it now? This function here is one-to-one. So this one here was our answer. And then here they're saying, is this guy even? Is this guy odd? Or is it neither? Or is it both? Okay, so here the tests are these. So if it's even, then f of x will just be equals to what? F of minus x. And then if it's odd, it means that f of minus x will be equals to minus f of x. Okay, so I'm not sure this is neither, but let's try. Let's try. Okay, so let's find f of minus x. Okay, so f of minus x, if I say f of minus x, if I put minus x and then I raise it to a power which is even, like 4, okay, it means I'll retain the same value. This one is maintained, and then minus, and then if I say minus x to the power 3, this one here ought to be minus x to the power 3, and then plus this negative outside here, this will end up being x to the power 4 plus x to the power 3. So we see that f of x here will not be equal to the what? F of minus x. So it's not even. And then we try the odd, so we just say minus of f of x. So minus of f of x, it gives you what? So you multiply whatever you have here by a minus. You're going to get minus x to the power 4. And then negative multiplied by this negative here. You're going to get plus x to the power 3. So you see that, okay, so you see that the f of minus x here is not equal to the minus of f of x. Okay, they are not equal. They are not equal. So since this condition here is not satisfied, even this condition here is not satisfied, then this function is neither even nor odd. It's none of them. Okay, so your answer here should be this one, neither odd nor even. Okay? I hope you followed that. Okay, and then here they're saying which of the following functions is one-to-one. Okay, so you just have to apply the same test that we did. Save it. Okay, so I can say that the first one is one-to-one. The second one is one-to-one. The fourth one is one-to-one. The only one which is not one-to-one here is this C here. Why am I able to identify it? Because I can say square root here. Remember what I said about a square root. So this one here on C, it will lead you to a situation where you have a squared is equals to b squared. And then when you take the square root here, you have two values. You have plus or minus a, which is equals to plus minus b. So if I pick a positive a here, and I pick a minus b this side, that condition for one-to-one, which is a is equals to b, is not satisfied. Okay, so that's how you can use the theorem. So whatever function has a power 2, okay, whatever function has a power 2, it will never be one-to-one unless you limit the domain. Why? Because these are quadratic functions. So when you draw them on this axis, they come like that. Okay, they can be like that. So if you draw a horizontal line at any point there, it will cut this graph at 2 points like that. So if it cuts the graph at 2 points, then it's not one-to-one. But all these others here, when you draw them and you draw that horizontal line, it will just cut them at 1 point. So they are one-to-one. So I think that's another way they can ask you a question. Okay, then number 10 is on completing the square. Yeah, so I think this will be my last question. My PC is about to go off. Okay, it's about to go off. So let's complete the square here. So when they say which of the following can be expressed in the form of this, they just want you to complete the square on all of these here and see if they give you whatever we have here. Okay, so when we complete the square here, this first one definitely cannot be the answer. It cannot be the answer. And the last one here cannot be the answer. So the only possible the two options that we have is B and C. So let's try to complete the square on C. So you have 2x squared minus 12x plus 13. Let's try to complete the square here and see if it gives us this guy here. Okay, so we have this guy. So we have 2x squared minus 12x. And then what was the last value? Plus 13. So we have plus 13 is equals to 0. Okay, so how do you complete the square? Remember what I said. I said you write 2x squared the way it is minus 12x squared. Okay, and then now you start manipulating. Okay, so after you write this and then you say plus, you get half of this number, the coefficient of x. Okay, what is the half of 12? The half of 12 is minus 6. So you say minus 6 and then you square it. Okay, and then after you add this, you're going to subtract it. So you're creating what we call as the special zero there. You add it and then you subtract it. Okay, so you're going to do the same thing here. So minus 6 and then squared. Okay, and then plus 13 is equals to 0. Okay, what are we going to get here now? So what you realize is Okay, I see. I've made a mistake here. You guys have not reminded me. I said you can't complete the square when the coefficient of x squared is not 1. But none of you guys. Anyway, okay, so we are going to do the same steps, but we have to make sure that the coefficient of that guy is 1. Always. Okay, so you can't complete the square if the coefficient there is not 1. So what are we going to do here in order to make sure that the coefficient here is 1? Okay, we are going to factorize it. Okay, we're going to factorize it. Okay, so this is f of x is equals to this. So you can't complete a square if the coefficient of this is not 1. Always, you have to factorize it. So 2, I factorize it from here. I'm going to remain x squared minus here to be 6x plus, okay, if I factorize the 2 from here, it means I'll remain with 18 over 2. And then here now we can complete. Okay, so it will be 2, and then here now we complete this. So what do? We write x squared minus 6x. Okay, and then now you start the manipulation. So you say plus. And then half of minus 6 is what? Minus 3 squared. And then you say minus the same thing, squared, and then plus 13 over 2. Close the bracket. So we're going to have 2, okay? And then here from x squared all the way to minus 3 squared, this is what we call as the perfect square. So we're just going to get the x from here and the minus 3 from here. This minus 6, we forget it. We ignore it. So we are going to say x minus whatever coefficient is inside here. And then we are going to say squared minus, then what is minus 3 squared? It is 9. So we're going to write 9 plus 13 over 2. Right? Okay, and then let's try to add this to see what we are going to do. So we are going to say 2, and then x minus 3 squared, and then let's add this. What do we get when we add this? So we are going to say, I'll write it as 13 over 2, and then minus 18 over 2. Okay, why am I writing it like this? So that it's easy to add. Okay, so this minus 9 here is the same as minus 18 over 2. So the common denominator now is just 2 here, and then I have 13 minus 18. So what is 18 minus 18? It's minus 5 over 2. So when I add whatever I have here, I'll just have minus 5 over 2. So now let me rub this and put the minus 5 over 2 there. Okay, so this will be minus 5 over 2, like this. And then we can multiply throughout with these 2. We are going to get 2x minus 3 squared. Okay, and then 2 multiplied by 5 over 2. It means this 2 is going to cancel with this 2 here. So we're going to remain with minus 5. Okay, so when we complete the square on whatever we had there, we're getting this guy here. And this is the exact thing that is in the equation. You see this guy here. Okay, so this one here on C is the only one that can be expressed in this form. Okay, all right, so the answer here is C. All right, so any questions on completing the square? Okay, so no question. I think I'll end here. So my PCU is going to switch off. Okay, so have a blessed night and continue studying. Okay, all the best tomorrow as you write your test. 2, everything that you need, okay, for a test is there on Drive. So just use the Drive properly. Okay, all these concepts, they are there on the Drive waiting for you. Okay, so have a blessed night, guys.